Hey, welcome to our marketing research final project presented by Audrey McFall, Lane Henry, and Emma Barr. So a little bit of background before we get into the main part of the presentation. With the way society is trending and technology is becoming more and more prevalent, ideas like self-driving cars and robots are becoming more and more accepted throughout society. And so we wanted to see how comfortable people really are with robots driving a car. And to test this, we used the variable of weather to see if the opinions of people changed when it was good or bad weather.
Let's get try.
This is the Tesla truck, which is an example of a self-driving car in today's society. Tesla is leading the industry as far as self-driving cars goes today, and things are only getting bigger as this car just came out, and you can see both the exterior and the interior kind of futuristic looking, and it's becoming more and more accepted. Our theory in this project is that if there was good weather, the typical person would be very trusting and willing to have a robot drive a car as they would a human. But if the weather was bad, that somebody might rather have a human drive the car because they just wouldn't quite trust the robot yet. This slide shows how the weather is the factor that really changes things in this experiment, where the robot might be driving the car, but the weather comes into play and can really just throw things off by just changing people's opinions. So now that you know our variables, we're just going to kind of explain that initially we assumed the weather was good, and so we just tested how people felt with the robot and with the human. And then when we manipulated the weather and made it be bad weather instead of good weather, we tested it again to see how this might change the way people reacted. Our questions were all formatted using the semantic differential scale with different scenarios for our experiment. And so we would always get one question of the four that we had that would come up for the survey taker, and it would ask about the overall evaluation of the robot and give three very similar statements, and you would have to rate what you felt 1 through 7 based on these statements available.
So for our participants, we each reached out to our families, sororities, fraternities, and other students that attend Clemson University. And because we have 3 people for our group, we were able to collect a good amount of information from a variety of sources. And I think we got about 70-something responses. Here's a screenshot of our regression output, which we were able to generate by importing the data from Qualtrics into Excel and then manipulating it in order to get each of the statistics that we were looking at. One of the statistics that we paid close attention to was the R-squared value, which tells us the amount of variance in the dependent variable that can be explained by the predictors. Our R-squared value was nearly 0.08, which was significant given that it's close to 1, therefore our mean data was somewhat clustered, therefore consistent. The next variable was the adjusted R-squared, which was less than our unadjusted R-squared value, which would lead us to believe that we were testing too many variables. However, in a 2x2 experiment, especially given that the difference in the R-squared values was less than 0.01, that was not really a concern for us. The last important statistic that we paid attention to were p-values, which are the likelihood of observing a strong relationship between the variables being tested. And the p-value that was most important in our experiment was the robots, which had a p-value of roughly 0.3. Therefore, it means that having the robot as a driver affects the outcome the most in comparison to our other variables.
After interpreting our regression output, we put the information in a 2x2 graph so we could put it into a bar chart. In our bar chart of humans driving versus robots driving, you can see that whenever there is good weather, humans are preferred to drive as well as when there is bad weather. But there is a bigger difference in want of a human in the bad weather. By looking at our bar chart, we noticed that our hypothesis was incorrect. For those that we surveyed, people are generally more comfortable with humans driving, especially in bad weather. Therefore, our second assumption, that people would be more comfortable with humans driving in bad weather conditions, was correct. Confounds involve changing more than one thing between versions of questions. This is acceptable because we are conducting applied research, looking to learn about a specific issue of a group. After realizing that our hypothesis was incorrect, we thought it would be important to do an error analysis. We think that part of our hypothesis may have been incorrect because of the world's growing acceptance and enthusiasm regarding technology. For instance, with the invention of self-driving vehicles, there's wider acceptance for robot drivers, which we did not take into consideration, but we assume this phenomenon will keep trending. We learned many things while doing this project. First, we learned how to effectively use Excel to make a regression analysis. Second, how to interpret a regression analysis output in context. In conclusion, as the world continues to trend in the direction of technology, it is likely that the results of this survey gradually change in favor of the robots. As technology becomes more refined and mainstream, people will become more comfortable with the idea of a robot driving no matter the weather. Lastly, we want to say thank you so much for a great semester and piquing our interest in marketing research career field. And we hope you have a great Christmas break.